Alright, we are recording. My screen is sharing, I think, so yeah, please post in chat if you can see my screen now, just to make sure. Can you see it? Can you see it? Oh. Alright, so yeah, I think while other people join, maybe now would be a good time. So this is the new sort of lesson plan that they want us to do. So before each lecture, I'll post like maybe a video explaining what you'll be learning in that lecture. Either that, or I'll give you sort of detailed page numbers for you to read in advance, or some like practice code to work through during the week. So this is before the lecture. Alright, so the content that you would expect, we would give you some time to go over. But we would be doing this, right? So this maybe would take you an extra 30 minutes, maybe even an hour per week, just wherever you have time. But we would also reduce the class time to 1.5 hours. Okay. We would reduce the class time to 1.5 hours instead of 2, because one of the common bits of feedback is that 2 hours is too long. Alright, so these changes would be taking place from next week, right? Because obviously this material isn't prepared yet. So today will be 2 hours. But yeah, next week probably 1.5 hours. And the sort of structure of the class will be, so you'll be given this practice code during the week, right? That I would maybe WhatsApp you or give to you on Rex Tester. We would spend the first sort of 15 minutes of the lecture going through that code. Then 45 minutes of our usual sort of lesson plan, so theory and stuff, and then a break obviously, and then sort of an interactive session. So you guys would answer questions, we would split everyone up into Zoom breakout rooms and whatnot. Okay, I take it from the yeses. I don't know if those yeses were to being able to see my screen or to the new course plan. But what do you guys think of this? Do you think this is better, or what are your thoughts on that? Would you prefer this kind of structure? Okay, cool. So, and by this you don't mean what we're doing now. You mean that. Yeah. Okay, I take it. Cool, and that's got a like. That's a good. You can like Soham's message there if you agree that this new plan is better. Awesome. Okay, then we can switch to that. Sure. We can see about doing that. Weird that attendance is so low. Not sure. Cool. Okay, let's get started. It's a pity, because then the other students are not going to be up to date on what the new plan is. Oh wait, okay, we're on this. Cool. So I'm going to spend some time revising just to get us back on track with where we were last week. So last week we were discussing memory and events. All right, memory and events. We hadn't yet got into our discussion of events. We were still setting up our example for events. I don't know if you guys saw, but earlier up in the chat, in our general chat for the team, I posted the code that we wrote while setting up that example. Okay, so we discussed these two ideas of pass by value and pass by reference. We went through pretty detailed examples. I think everyone got this idea right. In one case, you make a copy of it and you give the function the copy. In the other case, you don't, and you give it the actual memory address. All right. Don't want to spend too much time revising this idea. If someone feels that it's important to go over it again, then maybe we can in the sort of revision session. The more important stuff that we got to was this little example of we used a content creator uploading a video called Connor's Pro Minecraft Gameplay. All right. So we had like a content creator uploading a video to YouTube, and we were sort of exploring the idea of how would we create this process with what we already know. Alright, so we created this exact little diagram here, we created in code, right? So we had a content creator who would upload a video, okay, through our video uploader class, and that class, or the object of that class rather, would go ahead and notify the creator when the video was uploaded, and would also notify our subscribers. All right, and we were just in the process of discussing why this was wrong and how exactly we could go about improving it. Okay, so I want to show you the code again that we wrote setting up this example, and we can see again, just remind ourselves, how would we go about doing this, and why is our way not exactly perfect. Okay, but you see, are you guys just saying this is better because the lectures are shorter? Remember, doing that extra work, I don't know, I guess it depends what kind of things we prepare, how difficult we make the little practice code things. I'm not sure what the plan is on that. Okay, so this is the code example we wrote. You guys have had it for a whole week now. Maybe some of you spent some time looking through it, and so I do hope you understand it fairly well by now, but I think let's go through it maybe one more time, just to really get down our understanding of this. Okay, so when we started writing this code, the first thing we did really was create this class video. Alright, and the video class just has a single property called name. It has its getters and setters. We remember what those are, I hope. Okay, so that allows us to, the get allows us to see name or read name, if you like, and the set allows us to set name, right, or change it, you know, mutate it or write to it. Okay, so we've got our little property here, quite simple. We also created a constructor. How do we know this is a constructor? Because it has the same name as the class, right? And this constructor just takes in a string called name, and it just sets our name property to that value. Okay, so it's not a super complicated class. It's basically the simplest class you could make, right? Cool. So that's how we started writing this code, and we also went ahead and created a video, right? You guys, or rather one of you guys, decided to name it Connor's Pro Minecraft Gameplay. I think Connor is not with us at the moment, right? Yo, he's not absent. I think we have to rename the video as punishment for missing the lecture. Do any of you guys have, because of the content before the lesson? Okay, cool. Yeah, that makes sense. Do you guys have any good renaming suggestions that I should rename our video to? Or should we leave it as Connor's Pro Minecraft Gameplay? I don't know. I feel like you can't be absent and have the example named after you. That's ridiculous. Okay, but we go ahead and we create a video object, right? So we have our video class, and how do we create a video object? We say video vid, so that's creating a variable of type video with the name vid, and we set it to a new video, and we give it the string Connor's Pro Minecraft Gameplay as its name, right? So that's just us creating an object of type video. Nothing too hectic there. Again, you should be familiar with those ideas from our earlier lectures. Okay, the next step would be uploading this video that we just created, right? That's a bit more challenging, and required us to create another class. Okay, we called this class Video Uploader. All right, the Video Uploader class, and it has two methods in it. Upload. Okay, so the upload method is what we'll call when we want to upload a video. Right? And in order to upload the video, we need to be given a video. So this method expects to be passed a video, which it will call vid. All right? But the method itself is very simple. So all it does is print out uploading and then the name of the video. So in our case, it prints out uploading Connor's Pro Minecraft Gameplay. Here, this comment here was just for illustration purposes. It doesn't really matter. And then it calls the uploaded method. Okay, so what was the purpose of the uploaded method? Do we recall? You can kind of see it by the name, right? So we have the upload method, which actually uploads the video, and we have the uploaded method. Okay, uploaded, it's past tense. So what we're trying to say here is we've uploaded the video now. So what must we do after that has occurred? Okay, so the uploaded method defines what we do after the video is uploaded. Okay, and all that does is prints out uploaded. Again, this comment was just for illustrative purposes. Just uploaded, alright, it just prints out uploaded, and then it creates another object. Okay, so this is our third object in a way. Okay, but let's explore this. So it creates a subscribers object. Okay, subscribers just has a single method that notifies the subscribers. Okay, just a single method called notify subs. Alright, and that just prints out a new video has been uploaded. Okay, so what's the flow here? We create a video, we create a video uploader, we go uploader, that's our video uploader object, dot upload, and we give it the vid that it must upload. That goes ahead, it uploads the video, it calls the uploaded method, which creates our subscriber object, which then notifies the subscribers. Okay. Again, we programmed this last week. We spent like a whole hour and a half on it. So hopefully you guys are still feeling pretty comfortable with it. And there's nothing new here, right? There's just methods and classes. They're all quite simple in and of themselves. What might be intimidating is getting into your head what the entire flow is. Alright, like understanding the entire step-by-step of what the computer is doing. But that's why we have this diagram. Okay, always easier to think of it visually. Right, we upload a video and then we notify the subscribers. So this is the flow of what's going on. Okay, so this is the example we set up last week, and what we must discuss now is why is this not how you would do this professionally? Why is it wrong? Okay, we did touch on this last week as well. We did touch on this last week as well, but I think it's probably worth discussing a little bit more now as well. Okay, so why is this way wrong? The main reason has to do with how you program in sort of large applications. Okay, if you're in a large organization who has like these massive applications, how would you do this, and why wouldn't you want to do it this way? Okay, the reason you wouldn't want to do it this way is basically because it's not split up effectively, okay, into separate ideas. You can see in our video uploader class, okay, we have a subscribers object. What do subscribers have to do with video uploaders? Like, how are these two ideas related? The thing is, they're not really, right? The video uploader has to notify the subscribers after a video has been uploaded, so they're related in that sort of way. But in our case here, our video uploader is actually creating the subscribers, right? And is calling to notify them specifically. So if I want to change something about a subscriber, I have to then change how the video uploader works. And that doesn't make sense, right? Let's say you're working at Google on sort of YouTube or whatever, and they tell you, okay, your job is to just change how subscribers are notified. You just have to change, I don't know, the name of the method or move it to another place. When performing that change, you don't want to have to think about the video uploader, right? To you, the video uploader is a completely separate problem, right? In terms of just the human idea of uploading videos versus notifying subscribers, we don't relate these two concepts directly the way it is in the code. Okay, so it mainly has to do with the fact that we want to compartmentalize, we could call it, compartmentalize, like separate into compartments, all of our code. Okay, we want everything to be split up and self-contained, so that if I want to change one bit, I don't have to change everything else. Okay, So it allows me to write code more safely and more easily. All right. Do you guys understand that idea? Do you understand how we've done it is wrong, at least broadly, so that you know why we're doing what we're doing in this next little bit? Is everyone comfortable with that? Any questions about that? Want me to be more specific, or? Okay. Looks like everyone's okay with this idea. Good stuff. Cool. So, how do we fix it? We have to go back to our slides to see how we actually fix this in a professional environment. Okay. And the answer is we fix it using events and delegates. Okay. Which is two new concepts for you guys. It is somewhat complicated. When you see it visually, it will look quite easy. All right. And it won't look too confusing, I hope, in the way that I'm going to explain it to you. But when you see it in the code, it might look a little bit intimidating, it might look a little bit strange. But what I want you guys to remember is the questions that you get given in the test about events and delegates will be theory-based, right? There'll be sort of multiple choice and things like that. There are maybe some coding questions, but there are also multiple choice. So it's like a multiple choice programming question. They'll say, which one should you use? So you really just have to understand it more on a theoretical level about what the function of delegates and events are. Okay, you don't have to understand the exact nitty-gritty of how you implement them in code yet, right? Unless you want to become a professional C# developer one day. Okay, so we've set up this example and I just talked us through it, right? And we explained why this example is wrong. Okay, so when doing this professionally, we would basically scrap everything we've done. Okay, so we scrap all of the code that we've already written. Okay, so we've just got ideas now. We've got the idea of subscribers, the idea of content creators, the idea of our site, to where we would upload videos, and the idea of notifying subscribers. Okay, and we want to think about a new way of relating these things. Okay. And the new way that we do this is called events and delegates. All right, events and delegates. And this is how you would do it professionally. So it's quite an interesting idea. So do pay attention. Maybe don't expect to understand it in complete detail immediately. It is quite a difficult concept, but maybe this will serve as a nice introduction, I hope. Okay. The basic idea of what we do here is we, instead of notifying subscribers directly, like this, okay, instead of notifying subscribers directly, we kind of go and we just give this idea that notify subscribers has like an ear, all right? It's listening for something, okay? And when the thing it's listening for happens, we'll go and say, all right, go ahead and notify the subscribers. But only when the thing you're listening for happens. Okay, so we give like a little ear to notify subscribers. All right? You can think about it this way. This is obviously only one way of thinking about it. There are many, but I thought this was a nice way of simplifying the concept. Okay? But obviously notify subscribers, it has an ear now, but it doesn't know what it's listening for. Okay? It doesn't know like what the sound will be, if you like. It doesn't know what the structure will be that it's listening for, what the events, if you like, it's listening for will sound like. Okay? So we need a way to define a contract or a signature. Okay? So the idea is that we'll tell notify subscribers ear, we'll go to notify subscribers ear and we'll say, this is what you're looking for. And we promise that when this thing happens, it will sound and look like this. It'll function in this way. All right? And how we define that little signature or that contract is called the delegate. Okay? So the delegate appears there, if you can see over here. The delegate appears there. You can see it has a certain shape, right? It has this shape around it. Okay? And almost what the delegate is doing is it's telling the ear that All right, when you hear something of my shape or hear something that sounds like me, maybe think about it as an I, if you like, rather, I don't know. When you hear something that sounds like me, exactly like this, you must then act. All right, you must then go ahead and notify the subscribers. All right, cool. So after we've set up this idea, we've told notify subscribers what it's listening for. We've promised that it will hear this eventually. Okay, it will. When it hears this, this is what it will sound like. Then we can basically proceed as we had before. So we'll have our content creator upload some new exciting content. Okay, and as soon as this upload has occurred, it will we'll just shout out. Instead of going ahead and notifying subscribers directly, we'll just shout. But we'll shout in the particular way that the delegate defines. Okay, like that. I uploaded a thing. Okay, and it just shouts out. Anyone who's listening, by the way, I just uploaded a video. All right. The ear hears this, and it hears that this is the same as the delegate. Right? It's the same as the delegate that promised that this is what would occur. Okay, and as soon as it hears that, it will just, you see it hears it, right? It hears it, and then it just goes ahead and immediately notifies the subscribers. Okay. So obviously this diagram is a simplification. I wanted to simplify the idea because it is quite complicated and abstract. There are some other ways to explain it, so if my way doesn't work for you, I'll also link in the YouTube video to another really nice explanation from another tutor teacher guy. But this was the way I thought to simplify it. And yeah, so we'll now go more concretely into what this diagram exactly means. It might be a bit weird to you, like, wow, this can actually be translated into code. But yeah, in a way it can. Obviously it's not an actual ear. All right, but we have this delegate here, this shouting out. Okay, this I uploaded a thing. This is what we would call an event. All right, an event, if you like. Maybe not don't think about it that way too technically. And yeah, and then the subscribers will go and be notified. Okay, but let's see more technically how exactly will we translate this sort of diagram into code. Cool. So we're going to use the same code that we created a while back. Let me see, are there any questions about the little example? No. Okay, are you happy with the abstract idea of why the slides way of doing it, the slides way of doing it might be better, right? Because you can see there will no longer be a direct relation between uploading the video and notifying the subscribers. Okay, subscribers will only be notified if it's listening. Okay, so there's no longer this direct strong relation there. All right. So basically we can change what happens here without changing too much what is happening here, okay, without thinking about any of this. Right, and we can do that because the delegate defines a contract between the two parties, right? We have on our event here, we have our listener or subscriber here, and there's a contract that the delegate defines. Okay, but yeah, let's see it in code because this might look a little bit abstract. Cool, so hopefully we understand the abstract idea of it and how we actually do it. I found this way quite nice to think about. I'll link it. Is that you can do it in sort of 3 steps. All right, 3 steps. Okay, so the first thing we have to do is create that delegate, right? Which will allow us to, which will define that contract between our subscriber and our event. Right, so we have to create a delegate. Okay, cool. We have to so yeah, first thing, create a delegate. Second thing, we have to create an event. All right, what do I mean by create an event? Basically we need to tell it how to do the shouting here. We have to tell it how does it shout out that it's uploaded a thing. Right, so we have to define that there. Okay, I think let's do this in 4 steps because it might make more sense. Okay, Cool. So we've got that. We then have to add our ear to notify subscribers. Okay, we have to add this ear. Okay. I'll explain in more detail what like this metaphor is suggesting. But for now, let's just think about it like that. I'll tell you when it happens. All right. And then 4, we have to actually shout. Right? We have to actually shout. So we told it how to shout, but we actually have to shout. The other way of saying this is to say we have to go and raise the events. Okay, raise the events. Okay, so if you like, use the event, like actually shout, right? So we've told it how, but it has to actually do it in order to work. Okay, cool. So we've got the 4 steps that we need to follow, and now I'll go through each step in the code, and we can see exactly what we need to do. All right. There is no, I think let's keep it this way. Yeah, cool. All right. So the first step is for us to create a delegate, right? The first step is for us to create a delegate. How do we do that? Well, we have to say public delegate. Okay, we know what public means, right? And we sort of know what a delegate is, right? It's defining a contract between our event and our listener. Okay, the other thing we might call this, the notify subscribers, is we can say that this notify subscribers is disconnect this in your head from the concept of an actual YouTube subscriber. Okay, the notify subscribers here is a subscriber to the uploaded event. Okay, so it's listening for that event, so you can see it as like subscribing to that event. Okay, this is why the video example is quite nice as well, because in a way you can see our video uploader, when it shouts like this, it's publishing. Right? It's an event publisher, and these guys are event subscribers. They're subscribing to the event. Okay. So we need to say public delegate. It has to have. Ooh, let me think. Yeah, I think that's correct. And then say uploaded handler. Okay. Cool. Ooh, let me think. I do want to double check quickly in the old code that I wrote, just to make sure. Sorry about that. That I'm not overcomplicating anything in order to make it work. C# events and delegates example. Yeah. Okay. Cool. We're on the right track. All right. Okay. So what is this defining? Okay, what is this defining? You can see it looks a lot like a method, right? Like if we look at our upload method, it goes public. Okay, it gives a return type. It gives us a name, and then it has the 2 open brackets, right? If we look at our other method, uploaded, it's public, void, it has a name, and it has 2 empty brackets, right? If we look at our delegate, it looks a lot like that, right? It's basically identical. It looks a lot like that. The only thing we've added is that we now call it a delegate. Okay? And the reason is it makes sense for this to be the case. Okay? What this delegate is doing is it's defining a structure for a method. Okay? So it's like a contract. It's saying, look, when this method occurs, when the uploaded event occurs, it's going to call a method that looks like this. All right? The method is going to be void, and it's going to take in no arguments. Okay. Cool. Don't worry if you don't fully get it now, but the idea so the delegates, think about it that way. The delegate is a contract or a signature. Okay. So it's saying like when the event occurs, it's going to look like a public void method. All right. That's what this is saying. Going to look like a public void method. Okay, but let's see that, or rather, this is what a subscriber will look like. But let's continue. Okay, cool. So that's the first step. We've created a delegate, like a contract or a signature. All right. The next thing we need to do is create an event. Right? Create an event. So how do we do that? Well, it's actually very similar. We say public events. All right. Now things get a little bit weird. Okay, so our event also needs to know how to shout, right? Let me show you it this way, maybe. Okay, so the delegate isn't just telling our subscribers what to listen for; it's telling our event what to shout, if you understand. So both parties, the delegate is like negotiating, if you like, between both of these parties, right? It's got the event, it's saying you must shout like this, all right? And it's got the subscribers, and it's saying to them, like, you must listen for this, right? When the event shouts, it's going to sound like this, and it makes sure that the event does sound like this. Okay, so the delegate is like a mediator between the two parties, if you like, making sure that the event shouts in a certain way and making sure that all the subscribers know what to listen for. Okay. So how do we display that in the code? Well, we have to tell the event what how it must shout. Okay, and the way we do that is we give it the name of the delegate. Okay, uploaded handler. Okay, like that. Uploaded handler. And then our event also needs a name. We're going to call it uploaded. Okay. Happy with that. So we've now created our event. Okay. So there's a little bit of a change that I want to make just to introduce you even more to how this is done properly and some of the standards that exist. Okay. So you can see now that our event is called uploaded, right? Which makes sense, right? So it's the uploaded event. Like, this is what we shout out the uploaded event when a video is uploaded. So this makes sense to call it uploaded, all right? But you can see that we also called our method here uploaded. Okay, so the way that this is fixed, the way that they've standardized it, is that the method that you call to raise the event, you call on uploaded. Okay, so on, and then the event that it's going to raise. All right. It does the exact same thing. We just call it on uploaded. So when the thing is uploaded, on that, call this. All right. And I want you guys to appreciate like why this is. Okay, no, we'll finish the example and then I'll explain. I'll explain more. But let me check. Are there any questions so far? No. Okay, I'm surprised. I hope that's not because you're intimidated. I hope it's because you guys understand. Okay. Cool. So now we've done that. We've said on uploaded. All right. Next step. We still haven't given notify subscribers its ear. Right? We haven't given notify subscribers its ear. So what we've done currently, we've created a delegate, we've created an event, and the delegate has told the event how it must shout. Okay, the shape of this. Okay, but we still need to give notify subscribers an ear, so that it knows what to do. Okay, so how do we do that? Well, our event, our uploaded event, is inside our video uploader. Okay. So we need to tell our notify subscribers method to listen. We need to give it an ear to listen for the uploaded event. Okay. So how are we going to do that? Well, what's cool is that we no longer have to do this inside our on uploaded method. Okay. We no longer have to do it inside our on uploaded method. Instead, I'm going to come up here where all our other code is. All right. I'm going to create a subscriber object. Okay, create a subscriber object. And now in that subscriber object, remember that's where our notify subs method is. All right. I want to add an ear to this method. I want to tell it what to listen for. Okay. So how do I do that? Our uploader object contains our uploaded events. Okay. So what I want to say is uploader, okay, our object. Okay, that's our object. Dot uploaded, that's our event. Okay. Uploaded. Okay, that's our event. I want to say plus equals. Okay. If you don't remember that operator, I'll explain it again to you now. Uploader.uploaded plus equals subs dot notify subs. Okay, so what has this done? This has told notify subs to listen for the uploaded events. Okay, so it's now a subscriber to the uploaded event. Okay. If you guys don't remember what the plus equals operator does, I can show you that now. So if I have like int x equals 6, for example, you know what that does? If I say x equals x plus 2, right? We know that this will make x equal to 8, right? Because we had int x equals 6. The thing on the left became x plus 2, right? This x is 6, so we get 6 plus 2, and that gives us 8, right? We're familiar with that idea? Okay. Instead of writing it this way, you can write it this way. Okay, x plus equals 2. Okay, so you don't have to write x twice. All right. So it's just a little shortcut. So all I'm doing is adding this subs.notify subs to all of the listeners for uploaded. Okay, that's all we're doing. All right. Hopefully you guys are comfortable with that idea. Okay. So we now have we've given subs an ear, we've created a delegate so everyone knows what they're listening for, and we've created our event. The last step is to actually shout, right? How do we do that? Well, now we just come to our onUploaded method and we just tell it to shout. And how do we tell it to shout? We just tell it the name of our events, uploaded. Okay, we just tell it the name of our event. And now when I run this, assuming I didn't type anything incorrectly, which, I mean, it is a lot of code, but we can see now. When I run this, it works. Okay, a new video has been uploaded. Okay, so it goes ahead and notifies our subscribers. But now we've really separated out the logic that allows us to do this. Okay, cool. So guys, I know events, delegates, they might seem quite scary, and it's fair for you to consider them that. These are like very advanced programming concepts. But I really want you to understand the principle of it. Like, why is this so powerful? So you see how easier it was for us to link notify subs to the uploaded method. So let's say we had a bunch of other things to do when a video was uploaded. Like, we need to notify people who have Bell subscribers. We need to start processing the video. We need to add captions to the video, right? We have to do all of these other things when something is uploaded. Okay, and the way you would do that is literally to just go and add all of those things you need to do. You can just say uploader.uploaded plus equals, and then, you know, like whatever name of method to perform when a video is uploaded. Okay, so what's cool is that all of this stuff can happen like as soon as a video is uploaded. Okay, if that is too abstract for you to appreciate, like how powerful that idea is, maybe I can give you just a few examples of where this concept is used. Okay, so yeah, let me show you that. So one super. Ooh, Connor's pro Minecraft. Ah, Connor, you joined us. That's good. Okay. Cool. So let's see. Have we increased in people a little bit? Okay, up to 11. I think we usually have like what 13, 14, 15, something like that. Joshua isn't here today though, so, and Benele hasn't joined. Let me ask him to join again. Okay. You're a bit intimidated. Okay. No, that's fair though. It is quite a difficult concept. But what I want you to understand, let me give you some other examples of where this is used. Maybe our example was like even a little bit too abstract, right? So one idea, let's take my mouse moving over this button here. Okay. So think about how you might program this if you don't have events and delegates. You might say, okay, this button is taking up a square of pixels, right? And you could program every single one of those pixels to go, okay, if the mouse is on this pixel, then the entire button must turn yellow, it must bring up this little pop-up, and my cursor must change to that pointing finger instead of the little arrow. Okay? That would be very difficult to do. You can see how much code you would have to copy, right? Like every single pixel needs to know that it's listening, right? And also every single button, right? Every single button. Because this works for every button. Do you want to copy paste that code again and again and again and again? No, of course not, right? So how do you do this? Well, you create an event. Okay, so the mouse moves around the screen, right? And when it mouses over something, it just shouts. It goes, hey, I'm mousing over something. Okay, this is a particular event. Okay, and any button that is interested in listening to that event can you just add its ear, right? You just add an ear to that button. Okay, you just add an ear to that button. And then all the buttons that have that little ear, when it mouses over it, will do that little animation. Okay, so that is actually how this is implemented. This is considered an event. Okay, it's not a C# event, but it is considered an event. Okay, that's how that's implemented. Okay, so and there are a bunch of examples of this, right? So, maybe that's not the greatest one. So we have video uploading currently. When something is delivered, that's a good example. So like if you're Amazon, you've just been told that a good has been delivered to a person's house. How you might implement this is with an event. Okay, you might say, okay, there's been an event, the product has been delivered to this house. Yeah, like Uber Eats as well. All of these things will use events, guys. So you don't want to program every single little interaction individually. Instead, you just go, hey, something has been delivered, and anyone who's listening for things being delivered will just check it and go, was this mine? Okay. So the event is very powerful. Like you just tell it what methods to. I had today, and I was watching the thing. So yeah, so you just tell it what methods to listen for. Okay. Cool. So yeah, it might be a little bit intimidating. We're going to go on break soon anyway, so maybe for the next sort of like 5 minutes, or rather like 3 minutes, let's go through this in a little bit more detail to see what exactly is happening. Okay. Cool. So the first thing we do inside main is we create a video object. Okay, we're super familiar with this by now, right? We just set its name to Connor's Pro Minecraft gameplay. It just goes to our video class. We don't really care about how that works at the moment, okay? We create a video object. We create a video uploader object, and we call it uploader. Okay. The more important things is you must remember the names of all of these things, okay? Our video object was called vid. Our video uploader is called uploader, okay? We also create a subscribers object, okay? Subs. That holds all our subscribers, right? in that subscriber method, there is, in that subscriber object, there is a method called notify subs that will go and notify all of the subscribers. Okay. Cool. So what do? We go into Uploader and we look for this uploaded event. Okay. This uploaded event will be called when a video is uploaded. Okay. We tell subs.notify subs, okay, that it must also call it, like it will also be called when a video is uploaded. Okay, that's what this plus equals is doing. Okay, when a video is uploaded, this event will be called. Okay, the uploaded event. A video uploader will shout out and it'll go, hey, look, I've uploaded something. Okay, and it'll call that uploaded event. We tell it that when that event is called, it must also call notify subs. That's what this line is here is saying. Okay. We then upload the video. Okay. It does whatever. It just uploads the video. It calls this method on uploaded. Okay. After it's finished uploading. Okay. The on uploaded method just prints out that the video has been uploaded, and then it calls the uploaded event. It shouts out, I've uploaded a video. Okay, and as soon as it does that, it also calls all of the subscribers. Okay, all of these. Okay, anything that you've added to the event, it will also call that. Okay, so that's it. That's all that's happening. That's the entire flow. Okay, so all this is doing is it's saying, look, when the uploaded event is called over here, you must also call notify subs. Okay, and yeah, and what the delegate is doing, okay, is telling uploaded and notify subs what structure they must have. Okay, so what do I mean by that? You see, notify subs is public void, right? Public void, and it has these empty curly brackets. It's not expecting you to give it anything. Okay, look at our delegate. It's public, it's void, and it has these empty brackets. It's not expecting you to give it anything. Okay, so that's what the delegate is doing. It's defining a little signature. And look, when we call uploaded, we don't give it anything. Okay, we also don't expect it to give anything back. It returns void. We expect it to return void. All right, guys. So that's the whole idea. It might seem complicated with the words that we're using, right? Like maybe if you haven't heard the word delegate before, you're not sure how this is related, but maybe, I don't know, like it does have this formal definition, right? It's like a person who negotiates. Yeah, a person sent or authorized to represent others. So you see it's representing these other methods. Okay, to entrust to another person. Okay, the elected representative. All right. So it means the exact same thing here, guys. It's a delegate. It's the representative for our methods. Yeah, good point. Yeah, page 40. I don't think the book's explanation is too fantastic though, hey? But we can see. I will also link another one, another YouTube video that's quite good on it as well. Although he covers it in more detail at like a more advanced level maybe. But maybe if you sort of gelling with my explanation here, then you can go watch that more complex explanation and it'll bring everything together for you. Okay, but that's events and delegates covered, and at least to me, that's the most complicated topic in the course, I think. I think that's the most difficult concept in the course. So if you can come to grips with that idea, then you'll be good. Yeah, no, I'll link it on WhatsApp as well, and in the description of the YouTube video. Okay. So, yeah. I think that's that. That's it for events and delegates. So the next thing we'll be doing is called interfaces. Okay, and I think interfaces are very cool. Alright, and what we'll do is create like a little adventure game. Alright, so There'll be goblins and dragons and different weapons that we can pick up to attack them. Okay, so we're going to create that little adventure game using interfaces. All right, and that'll bring us to the end of section 2. And then we'll probably do next week some sort of revision stuff and get started with section 3. And section 2 is the most difficult, I think. So if you're feeling okay now, then yeah, we did the same thing there. Yeah, it's a good example though. But maybe we can pick different weapons. We can make our game. Look, I mean, you'll be able to play it in a text editor. Okay? It'll be a text-based game, text-based adventure game, if you like. There's not going to be any graphics, okay? Because we don't know how to program graphics, and Rex Tester won't allow us to anyway. Okay. But yeah, we'll do that after the break. So we'll take a quick 10-minute break. I think let's come back at 3:05. Is everyone okay with that? 3:05. If you have any questions about events and delegates still, you can post them during the break as well. Oh, that's cool. Yeah. So, yeah, and they would have used interfaces for that. Interfaces is how you would do this professionally. Uvia, I've done some like basic stuff in Unity, mainly for my project, for my master's project, like generating terrain, some terrain from that looks like it was taken by a real satellite image, basically, and yeah, so that's what I've done in graphics wise. But I also there was like courses at WITS where we make like games and stuff in JavaScript and stuff, and yeah, those were fun. It's obviously like I can't do it to a ridiculously professional level, but if I wanted to get a job in that kind of industry, I think I could. But you have to work super hard in gaming because a lot of people want to work in game development, so they pay you less and work you very hard. It's not usually, at least from what I've heard, it's not very nice working for game development companies. Yeah, Unity is good for it. I don't know, I think Unreal is maybe catching up though. So how many programming languages do you know? Well, one thing that's nice about proper computer science courses, like at university, and I'd say this is generally true for most varsities, is that they won't really teach you a particular programming language. They're just all tools. I haven't, no. At least, maybe, I'm not sure. I can... What does he do? Does he make like games or something, or just videos about it? But to answer Saham's question, yeah, like they teach you programming languages as tools. So I'm pretty confident any programming language you want me to learn, I can pick up quite quickly and get to like a reasonable level. It's not like a restrictive thing. Because like over the course of a computer science degree, you use lots, all of them. Not all of them, obviously, because there's ridiculously many, but you use plenty. Maybe. I mean, I've watched a few like Unity game developer videos or something. Like where they do little experiments, like trying to make, mirrors and portals that you can run through and stuff like that. Yeah, there is some cool stuff you can do with those game engines. Okay. Oh, let me see. Cool. So we are done with events and delegates. Next will be interfaces. All right, we'll start that lecture here. Cool. So yeah, we'll get cracking at 3:05 around. All right. I'm just going to go get some water quick. Just how he makes games. Okay. Let's see, should we start this example from scratch? Yeah, I think so. So I'll save this code. You guys have been sent this a lot, so maybe I'll link to it below in the YouTube video. Okay, so hopefully that saves. I think it should. Should probably double check that though. And then we can get started on this next example. Very detailed interface example. I think, yeah, maybe this was the other classes one. Yeah, I mean, no, I think, yeah, let's just define our own one from scratch. Okay. But we can decide on different enemies and stuff to keep it fun, because yeah, like one of you mentioned, let me double check that this did update. Damn it, it didn't update. Oh no, it did. That's the wrong example. Bryanston High Events and Delegates. Tell me you updated. Oh, it didn't. Okay, I'll go through and update it myself, I guess. Okay, I think I have to click save again at the end in order to make it update. Okay. Anyway, in a fresh Rex tester file. Okay, there we are. Let's check out the slides and discuss what we're going to be doing. Maybe first we should revise. I don't think you guys need to revise virtual, but we must revise abstract methods. Okay, I want to revise this idea of abstract methods. Okay, so yeah, let's actually do that in the same context. I want you guys to decide on an enemy. All right, a type of enemy. Okay, so in the other class we used dragons and goblins. What should we use instead? What other enemies are there? Dragons are very cool. A flying cheeseburger. That's not a threatening enemy. Okay, tiger, that's a good one. Okay, we'll do tigers. What else should we do? Although I don't wanna make a game about killing tigers. That's mean. Tigers are endangered. Teeth. Yo, come on, guys. There must be better. Them Connors. That's a good one. Okay, we'll make a Connor. Ninja. Yes. Okay, a Connor and a ninja. Alright, those are pretty good. Does anyone have any... Okay, actually ninjas and robots is very cool. Let's do ninjas and robots. We already included Connor in our last example. I think... Oh, come on, Connor, you can't... You prefer our enemies being... You prefer our enemies being Connors rather than robots. You prefer our enemies to be Connors than robots. I think robots are a much scarier enemy, maybe. Maybe you can be our weapon. Instead of sword and bow, we can have a Connor. Who like bites the robot or something. Okay, no, but we can discuss our weapons when we get to that. Alright, but let's revise this idea of abstract methods. Okay, that's what I want to do first. Okay, so we're going to create a class enemy. We've seen a few examples of abstract methods. Let me remind you maybe where they could occur. Connor can shoot cheeseburgers. Now this is becoming a good example. Okay, so cool. Let me remind you. So we created polygons, right? We created polygons before, and they had an area method. And if we make that method abstract, okay, then the other methods can inherit it. Okay, other classes, I should say, can inherit it. Okay, and those classes could override it. All right. But let me just show you in code. But I hope you remember this abstract idea had to do with inheritance. Okay. So now, instead of saying we've got polygons, and like squares and rectangles, we're now going to say we've got enemies and we've got robots and ninjas. Okay. Cool. So, class enemy, and we'll create a class robot for now that inherits. Do you remember how we show inheritance? We put a colon, right? Colon enemy. Okay, robot colon enemy. Okay, like so. I think we probably won't be able to finish this example totally, but we can always continue next week, so who cares? Okay, so class enemy, class robot enemy. All right. Now, how might we do this normally? All right, we might want to have, what do our enemies need? They need a name. Okay, a name perhaps is a good thing for our enemies to have, and a they need a name and they need a way to attack. All right, let's say that they need a name and they need a way to attack. All right, so for now, let's define both of those in enemy. Okay, so how are we going to define a name? Well, that's quite simple. We'll say public string name, and that's going to need getters and setters, right? So that's just a normal property. By now, guys, I hope you are comfortable with this, right? It's just a property. It's a string, a variable that we can change and see. All right, so we've got that. We also need a way to attack, we decided. So public void attack. Okay, how are our enemies going to attack us? Right, how are our enemies going to attack us? Now remember, robots have lasers and ninjas have swords or bows. Okay, cool. Guys, so you're thinking way down the line when we're defining all these ninjas and robots, but right now I'm defining an enemy class. Right? A general enemy class. This isn't yet a robot or a ninja. You can see it's class enemy. Right? So unfortunately our attack method here, you can see, would have to be something boring. It would have to be like console.writeLine attacks, right? Something like that, right? Maybe we could give it a target eventually, but currently this isn't the best. It'll be like attacks you, right? Something like that, attacks you. That's not a nice way for an enemy to attack, right? We would much rather say that, look, enemies have to attack you, have to be able to attack you. Okay, enemies have to be able to attack you. But I don't want to tell you how the enemy attacks you, right? So I want you guys to pay attention to this idea, guys. This is the important thing, all right? We have a class enemy, right? We want enemies to be able to attack, but we don't yet know how they should attack unless we know what type of enemy they are. So guys, what word do I have to add here in order to tell C# that I want enemies to be able to attack, but I don't yet know how? What word do we add? Does anyone know? So we've been having like these fun discussions, but now in terms of this, how do I denote this idea? Think about what we're covering. Methods, this idea of inheritance. There was a certain word that I could apply to a method. What word would I have to put here to make it so that I don't know how to attack? Interface would be correct, but Yuvia, you've been watching the other classes' lectures. You shouldn't even know that word yet. Currently, there is a specific word that we've been using. So what this word means that my class can be overridden, and I am not allowed to define a body inside my base class. What word stops me from defining a body inside my base class? Think about it. What am I trying to do? I'm trying to like define the idea of attacking. Okay, no, so I didn't. Oh, okay, cool. Virtual is one way, but Judson, virtual would still allow us to define a body in the method, right? What's the other one? You're right about virtual, but what's that other word? No, so I didn't. Oh, okay, cool. Yeah. You didn't watch them, you just saw them. Okay. Abstract. Good job, Saham. Yeah. Cool. So, what I want to show you now is, now that I've added this word abstract to the definition of our attack method, it's going to say enemy.attack cannot declare a body because it is marked abstract. Okay. So what is this saying? It's saying, look, enemies have to be able to attack, but you can't tell them how to attack. Okay. That's what abstract means. Okay. Judson, virtual, would also sort of work here, but then I would still be able to define a body, which is fine because I can just override it later, but this idea of abstract is maybe better in this case because we don't even know how to begin describing a general enemy attacking. Okay, but yeah, okay, that's what the word abstract does. Okay, so you see it means that I cannot define how my enemy attacks. Alright, but you can see, so now I don't define how my enemy attacks, but if I run this, it still gives me an error, right? I must make the whole class of enemy abstract, sorry, like so. Okay, it still gives me an error, right? What does it tell me? It says robot does not implement the inherited abstract member enemy.attack. So you see, robot is inheriting from enemy, right? So robots have everything that enemies have. So a robot has a name, and it has this attack method. But you see, the attack method isn't defined here. So what this is saying is, you have to tell the robot how to attack. Okay, that's what this is saying. You have to tell the robot how to attack. So how do we do that? We need to say public override void attack. Okay, and we need to tell it, how do robots attack? Okay, console.writeLine. Cool. Now we can discuss these fun ideas. How is a robot going to attack us? Let's see, we had some objects. Robots have lasers. I like that one. The robots can extend their arms and punch you, and extend their head maybe. Lasers. I'm digging the laser one. If you want to implement your own ways of attacking, remember you will have access to all of this code, hey? So you're welcome to edit it and maybe add new enemies and stuff like that. Maybe that can be the assignment for next week. Okay. Cool. So we've got our robot class. We're going to say the robot shoots a laser at you. Cool. You guys notice we haven't set our robot's name. Okay. Does anyone know, how am I going to actually create a robot? How do I actually set the robot's name? What method do we need to be able to set that robot's name? What is that method called? It's been in a lot of our classes. Yo, Saham, you're on point with constructors, hey? Because I remember you answered the last constructor question last week as well. And Saham, do you remember the special rule about constructors? What's the special rule? I mean, there's even two of them, right? Do you remember it? How do I create a constructor? Right, so I'll say something like public. What will I call my constructor here in the robot class? Does anyone know? Does anyone remember? What must we call the constructor in this case? Maybe what's scaring you guys is because it's inherited. Okay, but what's the name of this class? Let me put it that way. The class we're working in now, what's its name? Ooh. Yeah, you see, okay, so I think what's confusing is maybe like, because we've got this enemy class, right, and we've got robot enemy, okay? But you see, this class robot, okay? The name of our class is robot, all right? It is inheriting from enemy, okay? So the name of our class is robot, so the name of our constructor must also be robot, okay? Because it has, your constructor must have the same name as your class. Okay. Now, why do we have this constructor here? Why do we have this constructor here? We want to set the name, right? We want to set the name. So, what type will my constructor expect? How many variables? What type must they be? I'll leave the code on the screen. I won't be able to see the chat, so I'll just flick back in like 15 seconds maybe. Okay. Our constructor is going to have to take in some variables, right? In order to be able to set them. What type will it have to take in, and what must how many will there be? How many and what type? Okay, we're trying to set what? The robot's name, right? Okay, it's going to have to take in a string, and I assume you only said string, so you mean one string, I hope. Okay. So it's going to take in a string name, all right? And it will just say name equals name, and that's going to set the name of our robot, okay? And we can create as many robots as we want, right? I'm going to show you, I'll remind you, there's this little trick that we used to print out Connor's Pro Minecraft gameplay, right? The name. So instead of saying the robot shoots a laser at you, our robots actually have names now, right? So instead of that, we can actually print out the robot's name. Okay, like so. Name shoots a laser at you. Okay, and it's just going to replace name here with that property. Okay, so this is like a little template. It's going to replace the name and those two little curly brackets with the name of the robot, and the way you tell C# that you're doing that is you put a little $sign before the string there, and then it knows to look for this template. Okay, so if we call, we'll decide on robot names later. Okay, well, shall we see if this works? I'm not sure if we made any little syntax errors, but let's see. Okay, so what do we need to do? We need to create a robot, right? How do we create a robot? Well, we say robots, I'll just call it bot. Okay, robot bot equals new robot. And we have to give our robot a name, right? Because the constructor expects a string name. So I need to give this a string. And what shall our robot's name be? We can call our first robot Connor. But wait, no, Connor was our... no, you know what I'm calling the robot is Soham. Okay. There you go. Because Connor was going to be a weapon. How can we have our weapon and our enemy both having Connor? We won't be able to distinguish between all of the Connors. Okay, cool. So our first robot is Soham. Yeah, exactly. But for making the suggestion, our first robot is called Soham. I thought you guys would recommend, like, I don't know, some weird, like, acronym, like RC32 or something. But whatever. Cool. And then we can tell our bot to attack us. And when our bot attacks, it must print out what? It'll print out Soham shoots a laser at you. Okay. So bot dot attack. Like so. And hopefully if there's no errors, it works. Cool. So it says Soham shoots a laser at you, and obviously we put an exclamation point there because it's intense, right? Okay, Soham shoots a laser at you. Alright. So we've got bots working. Okay. Cool. So, yeah, let's. We still have plenty of time. Yeah. So let's go ahead and actually, the point of this was to revise what abstract meant. Okay. So, guys, what does abstract mean? It means you do not define the body here, right? You do not define the body. You're just saying, look, all enemies need to have a public void method called attack that takes in these parameters. Okay, that's what this is saying. All right? It doesn't say anything more specific than that. That's what abstract means. Okay? And in order for something to hold an abstract method, in order for a class, our class enemy, to hold our abstract method attack, our class itself also needs to be abstract. Okay. Cool. So, this idea... I'm thinking back now. Yeah, so this idea is basically what an interface is. Okay. So an interface is a class, basically. There are some slight differences because that this allows you to do, but in general, what you can think about an interface as being is a class where everything is abstract. Okay? Everything. All the methods, all the properties, everything is abstract. Okay, guys? Little weird, but think about what that allows you to do, right? Here I had to... it is basically just a faster way of typing initially until we see... there are some extra features that interfaces allow us to do. But in general, what you can think about this as being is, instead of writing abstract class enemy, here I would just write interface enemy. And then I no longer have to say public abstract. Okay? Ooh, that's the other thing. It's not just that everything's abstract in an interface, it's also that it's all public. Okay? So it's like a class where everything is public, everything is abstract. Okay, so it just saves you on typing a lot of stuff. But also, there are some other powerful things that allows you to do. Because if it's an interface, C# can guarantee that everything is abstract. It allows it to do a lot of extra things with that information. Okay, but that's what an interface is, basically. So if you understand what this abstract method is doing, it's just saying, look, you have to have a method that returns void, that's called attack, and that takes in these parameters. In this case, we don't have any parameters for attack to take in, but you get the idea, right? I could have said like string target or something, okay? In which case, this would have to take in a string, okay? But like the idea is that this is just saying all enemies have to be able to attack. That's what this is saying. Okay, by saying public abstract. We don't know how, right? We're just defining an enemy. We don't know how enemies attack. We don't know if it's a robot or a ninja or a dragon or whatever. But we do know that all enemies must attack. And that's what this abstract word allows us to say. Okay, so instead of writing all this, you can literally just go interface enemy, and then you no longer need to say public abstract. Okay, void attack. No longer have to say override. I think it might complain. Yeah, that's fine. We'll complain about public. Okay, and it'll probably also complain about name. So we have to come here and say string name get set. Ooh, interfaces kind of. Ooh, sorry about that. Let me think about this. Get set. Okay, semicolon after method. Ugh. Okay, Should go more smoothly now. There you go. So it works. All right. So what has this changed? Basically, all it changed, I no longer type public here, right? Because everything in the interface is already public. Okay. I no longer type public abstract here because everything in the interface is already public abstract. Okay. So all the interface is doing is it's forcing everything to be the same, basically. It all has to be abstract. Okay. So all this is saying is, look, we've got an interface called enemy. Enemies have names. I'm not telling you anything more about the names. Enemies just have names. And then it says enemies can also attack in this particular way, right? The attack method has to return void, and it can't take anything in. But it has to do this. Okay. That's all the interface is saying. They have names and they can attack. The class robot that inherits from enemy has to do all the other work. It has to tell it how to use name. It has to tell it how to attack. Okay. Cool. So let's now go see this in a slide. You've now seen what interface is kind of doing. It's just making everything abstract, right? But why is this so much cooler than what we've been learning before? All right. Interfaces. Yeah, I like this topic. It's pretty fun. Okay. So yeah, similar to classes, but everything is abstract. And hopefully you know what that means now. It means, you know, nothing is concrete, right? Nothing is nailed down. It's all just ideas. Okay. Cool. So let's consider an example where we create a weapon interface. All right. Now, how do we denote interfaces? Usually, if it's an interface, you put an I before it. Okay. It's not a rule. You just saw an interface that works without that I, right? Our interface was just called enemy. But in general, how you write this in the real world is you'll say interface IEnemy. Okay, because that makes it clear what we're working with. All right, it's clearer that this is an interface now. Okay, so our interfaces, their names start with a capital I. Okay, that's just a general. It's better practice so that when you come back to your code and when other programmers look at your code, they all recognize that you are working with an interface. Okay. Cool, and it works similar to inheritance, right? It's just everything is abstract. So you inherit bow, I weapon, sword, I weapon, okay? You can see bows and swords, they both attack in somewhat different ways. You know, they work in somewhat different ways, but there's similar ideas there, right? Both of them are weapons. Okay, so they inherit from this I weapon interface. Okay, and we can do the same with enemies. All right, IEnemy. We've got dragons and goblins here, but actually in our case we decided we're going to be using robots and ninja. Okay. Wait, was that our decision? Yeah, we did decide on robots and ninjas, right? Yeah. Ooh, yeah, and we also hadn't decided on another weapon yet, hey? But we can update that next time. All right. So we've got an IEnemy, right? We know what an enemy is, right? We've got an interface for enemies, and robots are enemies and ninjas are enemies. And again, they're similar in specific ways, right? Like robots attack, ninjas attack, robots have names, ninjas have names, but they're also different in that like ninjas will attack in a different way to robots, right? But they're both enemies. Okay. So currently, how we might go about defining this is we would say, okay, I have my weapon, all right, and with my bow, if my bow is a weapon, I could attack robots, all right. Alternatively, I could say, with my sword, I can also attack robots, all right. That won't do you much good, I don't think. And my bow can also attack ninjas. And my sword can also attack ninjas. So you see we've defined like 4 relationships here, right? Bows can attack robots, bows can attack ninjas, swords can attack robots, swords can attack ninjas. That's a lot of work. That's a lot of programming. So instead of doing all of that, we can just say actually, you know what? All weapons can just attack all enemies. Right? All weapons can attack all enemies. And then I don't have to define all 4 of those relationships, right? Because bows are weapons, swords are weapons, and as a rule, weapons can attack enemies, right? Robots are enemies and ninjas are enemies. So I don't have to say weapons specifically attack robots or weapons specifically attack ninjas. No, they're both just enemies. So I can just define one relationship instead of all 4 of these. Okay. So that's why the idea is quite powerful. And essentially all our weapon interface is going to say is that if you implement the iWeapon interface, or if you inherit from the iWeapon interface, so how we could say is bows implement the iWeapon interface. If you implement the iWeapon interface, you must, okay, you have to provide a way to attack enemies, okay, IEnemies, the IEnemy interface. Right. And you'll see that this relationship here, this graphic here, allows us to very quickly define a very complicated game, actually. Like, there's a lot you can do here. You can pick a bow or a sword. You can use that bow or sword to attack a robot or a ninja. Okay? There's a lot of stuff you can do here. And it's very easy to add another enemy. And if I add another enemy, then already, as soon as I add that enemy, if it inherits from IEnemy, then bows and swords will be able to attack that enemy as well. And so then suddenly we have 6 relationships. And if I say add another enemy after that, suddenly we have 8. Right? If I add another weapon, you can see it scales up hugely, right? Like if I go and add a gun now, and I have 4 different enemies, right? That's now 12 relations being defined. But it's all instant. You just have to add that one extra thing, and it will automatically be able to attack robots, ninjas, whatever other enemies you have. Okay. So that's why this relationship is very powerful. It allows you to very quickly build lots of complicated relationships. Okay, and this is actually how you would develop in games. You would define interfaces for all of these objects, and yeah, you would do a lot of things like this. In fact, basically all professional programming, if it's done properly. Okay, which is saying something. It is difficult to actually think about a problem in this way. This is quite an easy one to frame, but you can picture if we're working with, you know, employee data or something boring like sales or whatever, you can see that this would be more complicated to define, right? The relationships between all these objects. But there will still be these relations, and they will be defined through interfaces in a system that's built properly. Okay, but we also decided connors and clubs. That's what I was expecting to see when I came back to this. So what weapons are we going to have? Connors and clubs. That's not bad. Yeah, you see lasers and shurikens are used by the robots. So yeah, our weapons are going to be connors and clubs. That's a good suggestion. I mean, swords are pretty cool. Huh. Okay, I don't know. Let's go with connors and clubs just to be unique. Okay, so our one weapon will be connors. I hope you guys managed to follow when I'm referring to connor as a weapon. Okay. And our other weapon is going to be a club. Okay. Cool. And so what this is now going to say is, yeah, you can see that this would still work. Alright, it's now that connors will be able to attack robots and clubs will be able to attack robots, and connors will be able to attack ninjas and clubs will be able to attack ninjas. Okay, so let's actually start programming this up, and we can also have some fun programming tasks for next week as well, in sort of while setting this up. Okay, so we've got our interface IEnemy, right? And we've also got a class robot that implements the IEnemy interface. So when we're talking about classes, you're used to using, when we have a colon like this followed by another class, you're used to saying inherit, right? And that's good. When we're referring to inheriting from a class, then we say inherits from a class. But when we're talking about an interface, we don't say inherits IEnemy. We say robot implements IEnemy. Okay. Why do we say implements? Because IEnemy doesn't really provide much to inherit. Okay. Everything that you inherit or take from IEnemy, you actually still kind of have to do yourself, right? The IEnemy says you must attack, and then you have to implement an attack method. It says you must have a name, and then you have to implement the name property. Okay, so like the interface isn't providing much to inherit, right? You implement interfaces, you don't inherit them. Okay, that's just the word we use. Hopefully that's not too freaky for you guys. It makes sense, right? So are you using Rexter or something else to compile this code? I'm using Rextester. It's white, I think, after you log in. I know it's weird because when you visit the site, normally it has like that gray background. But yeah, I am using Rextester to both run and compile this so that I'll be able to share it with you easily after we're finished. Okay, cool. So we've got our interface IEnemy, we've got class robot, alright. What's left on our diagram here? We need to create, let's not think about weapons yet. Okay, let's focus on enemies. We need to create a ninja enemy. Okay, so let's go ahead and do that. Alright, so how would I do that? It'll be very similar to how we created our class robot, right? Basically identical, okay, except it'll be a ninja. Alright, so we've got our class robot IEnemy. I'm just going to follow a similar structure. Guys, I want you to note down how I do this, because I think a good assignment for next week will be you adding your own enemy to the game. Okay, so any enemy you like, right? So I'll add ninjas here, and you can try to add your own in the same way. Alright, so I'll say class, so we're going ninja, right? Ninja IEnemy. It inherits from IEnemy. Right, like that. Okay. Cool. When we inherit from IEnemy, we need to implement both name and attack. Okay. So we're going to say public string name get set. Okay. Public string name get set. Cool. So we've implemented our name property now, right? So that's one job done. Next, we need to implement the attack thing, right? The attack method. And what is it? It needs to be void, and it mustn't take anything in, and it has to be called attack. All right. So we do that. We say public void attack, like so. Okay. Happy with that. So we've now implemented the attack method, but obviously we want to go more in depth, right? How do our ninjas attack? Console.writeLine. Okay. We're still going to use their name, right? So we're going to put a little $ before it and say name in these curly brackets so that it prints out the name of the ninja, and then it says what they do. Okay. Ninja can dash and attack fast, yeah. But would dashing do damage? Dash and attack fast, attack quickly. Should we say name attacks you quickly or dashes at you? What about throwing a thingy? They're called shurikens. That's what a shuriken is, right? Shuriken. Yeah, that's the one. Is that how you spell it? Let's double check. I'm not sure how you spell shuriken. That's it. Okay. Yeah, I mean, this is how I picture a ninja attacking someone. Definitely. One of these thingies. Right? That's very ninja-y. It's either that or dashing at you with a sword. But I think, I don't know, maybe shurikens are more, yeah. So it throws a shuriken at you. Okay. Again, if you guys want to change the attack methods, you can go ahead, right? Throws a shuriken at you. Wait, I forgot how to spell it already. Shuriken at you. Okay. Cool. And we need to create our constructor. Alright guys, this time I'm going to ask you again, just to make sure. What will our ninja constructor be called? How many variables will it take in? What will our ninja constructor be called, and how many variables will it take in? It's going to be called ninja. Good stuff. But ninja with a capital N, right? C# is case sensitive. Remember that when you're creating your own ones. So ninja, exactly. And what will it take in? What will it expect you to give it? What do ninjas have? Just like robots. String or strings. It's going to take in one string, right? And it'll basically be the same as the robot constructor other than that, right? So we'll say public ninja, okay, like that, and we say string name, like so. All right, and we'll say name equals name. Okay, so that'll set the name of our ninja. Okay, cool. Shall we try creating a ninja? We've created a robot. Let's create a ninja. So we say ninja, nin equals new ninja. Okay, and what should our ninja's name be? Anyone volunteering to be a ninja? I mean, Yuvia brought up shurikens, so that's a ninja, but okay, we'll call our ninja Yuvia. Alright. Cool. Shall we see if cool, we've done bot.attack, but we can also say now nin.attack, right? Nin is the name of our ninja object, whose actual name is Yuvia, but we don't need to know that to work with it in the code, right? Obviously, we don't need to know things this specific, right? So our robot, whose name was Saham, could also attack, and our ninja can attack. Now, how are we guaranteed that both of these have the exact same method? Well, because they both implement the IEnemy interface, right? And IEnemy says you have to have an attack method, okay? So when I say nin.attack, it will say something different to bot.attack, right? But both of them are attacking, okay? And we can guarantee that both of them are able to, right? So now it says, Saham shoots a laser at you, Yuvia throws a shuriken at you. Okay. Good stuff. So we've now got 2 enemies in our game already, and that wasn't too difficult, was it? And you could very easily add more, right? Yeah, and I think that's a good coding assignment. I want you guys to add 1 more enemy. Okay, whatever enemy you like. Okay. We have like 13 minutes left. I'm not sure if I want to... I mean, we will only be going for 1 hour and 30 minutes from now on, so maybe we should get as much as we can into this lecture. Okay, Joshua, who is the protagonist? So Joshua sending Connors to attack Yuvia and Saham. Good stuff. I'm liking this game. Okay, so what we have to do now is define weapons, right? So we can see, like, in our little structure here, okay, weapons, we'll have Connors and clubs. All right, but first things first, we have to define this iWeapon interface. All right. So how will I go about defining this iWeapon interface? Well, firstly, we just say interface iWeapon, right? Interface iWeapon. Okay, like that. What things does a weapon need, guys? What would a weapon need? It's pretty simple, actually, right? Yeah. Well, you won't be able to edit mine directly. So you'll have to. You can go on Rex Tester when I share this with you afterwards, and you'll be able. There's a button at the bottom that says Fork It. If you click that, then it'll open up in your own version of the code. Okay, but then also one other thing to note, if you want to do it in a different way, like if you want to implement it in Visual Studio instead, you can just copy all of the code into Visual Studio and it'll still work. Okay, anything that can compile and run C#, it will work. All right, so you could also use .NET Fiddle, whatever you want. Okay, but I'll share the code with you in Rex Tester, and if you want to edit it in Rex Tester, you can click, there's a button that says fork it, but I'll show you at the end of the lesson. Okay. Okay, and amounts of damage, these are good suggestions. For the purpose of our game, there is a very particular method that our iWeapons are going to have. Right? For the purpose of our game, our iWeapons are specifically going to have to do one thing, definitely. Right? Let's look at our slide. Okay, skip through those little bits. Looking at this diagram, okay, what is a thing that our iWeapons definitely need? Okay, what is very clear on the diagram that the iWeapons definitely need? And if I open up this bottom thing here, it says the iWeapon interface states that if you implement an iWeapon, you must provide a way to attack an enemy. So what do our interfaces need? What does our iWeapon interface need? They need to be able to hurt enemies. Exactly. Okay, you can think about this. I mean, how would we attack an enemy, right? The enemies attack, right? So maybe we can look to them for some guidance. How does our IEnemy interface attack? Right? It has this void attack, right? Void attack. Well, if I just go ahead and copy paste that directly into iWeapon, that seems pretty good initially, right? That now our weapons will be able to attack, right? Our weapons will be able to attack. But there's something wrong here. Okay, hopefully you can see already. This weapon, right, this version of iWeapon, the attack method, it doesn't take anything in, right? It doesn't know what to attack. Hey guys? This attack method doesn't know what to attack. It doesn't take in a target, right? Now, you'll have to dig deep, right? What? Because this might be a bit of a tough question, okay? I'm telling you, this is going to have to take in, I'm not going to tell you what type it is, right? I'm not going to tell you what type it is, but it has to take in a type, target. Okay. What type will our targets be? What type will our targets be? Looking at this, all right. Right? When an iWeapon attacks, what type will its target be? What can we guarantee? When our iWeapon attacks, what type will its target be? Let's see, do we have any suggestions? Ooh, we're all saying string. Yeah, I mean, the type we're attacking definitely has a string, right? It has a string. They have names even. But like, surely our target needs to have something other than a string. Can't do much interesting with a string. So yeah, guys, think maybe, yeah, try to go outside of the box. I don't. We'll spend the rest of the lesson thinking about this, but really, like, think. What are classes doing? What is this interface doing? This IEnemy interface doing? In a way, you could see it as us defining our own type, right? The type IEnemy. Okay. What type are we going to be attacking? What things are we going to be attacking? Yeah. Okay. So it is a bit of a complex question, and string is the answer that I would expect from a person who hasn't seen the like this answer a lot. We have seen a method where we passed it a class, right? You've seen a method where we passed a rectangle, for example, into the method. All right, we covered that. I think it would have been last week. Yeah, I hope that's the case. But the type that this, because it is actually it's very cool. The type of our target is an IEnemy, guys. It's an IEnemy. That's quite cool, right? All of our weapons are going to define a method called attack that attacks IEnemies. All right. And yeah, we have been going for about 2 hours now, and I don't want to get too much into this whole iWeapon thing in the last 6 minutes, because we can explore that in the first 20 minutes of next week's lecture. Okay. For now, yeah, you've got this code to work with. We've added 2 enemies. All I want you to go and do for like the whole week, we can consider this our first programming assignment on that new thing, is go ahead and add your own enemy right here. Right? Add your enemy below this comment. Okay. So you're just going to hit enter, and right here add your own enemy. Okay, your own enemy. Okay. And we'll see how exactly we can work with this game a little bit more once we're done. Okay, let me just make sure that the code still runs before I share it with you. That we haven't got a typo in our... Yeah, cool. So it currently says, Saham shoots a laser at you, Yuvir throws a shuriken at you, you're going to add your own enemy below here, and obviously make sure that it works, right? So you're going to have to create an object of your enemy, like we've done with ninjas and robots here, and make your enemy attack. Okay. Cool. So, good luck with that, guys. I'll share this code with you on the WhatsApp group. What should I call it? I'll call it Bryanston High. Bryanston High. Will it not allow me to edit that? It will. Okay. Bryanston High dash interface example. Okay. So I'll call it interface example. I will share this with you. There is the link for it. Okay. Control C. Let me post it in the chat right now, actually. Oh, it always does this. I don't know why Microsoft Teams tries to share links like that. Make your own enemy. That does make sense as a name, actually. Maybe I can change the name. But I mean, this way works too, right? It shows that we're... Why does it always try to share links like that? That's so annoying. I don't know why. Oh! Okay, I don't know why it does that. There we go. That's what I wanted. Just a simple link. Come on, Teams. Alright, so that is the URL to it. Let me make sure that that works. Okay, and yeah, it opens up Bryanston High interface example. How you can get this yourself. Do not edit it directly here. Well, you can and run it, I assume. It might allow you to edit it, but it won't permanently allow you to edit this. Alright, so you're going to have to hit fork it, and you give it your own name, right? Like my own enemy or something, whatever you want to call yours. And remember, this will all be in the YouTube video. I'm still recording, so you can go through and check the example. Yeah, sure, you can set it to everyone can see, only me can edit, and we just click OK. Alright, and then it will give you a new link, okay, to your version of the code. Okay. The alternative, if you don't want to create a Rex tester account, I mean, I recommend you do, because it's quite a cool service, right? But if you don't want to create your own Rex tester account and go through all of this, then you can just copy paste all of this code. You must get all of it though from like using system. You'll go down, you'll copy paste all of it into whatever editor you want to use instead of Rex Tester. But ideally make sure that it can run C# code. Okay. Alright, so, and also when you edit it, go into edit mode. Okay, in the bottom right here, you'll hit edit mode, and then you'll be able to go ahead and edit this. Okay, and it'll also, it should, and you have to click save edits to permanently save the edits. Okay, cool. Hopefully that works out for you. It's not a super difficult thing though, and I won't, it's quite interesting too, so do try. Right, but also don't worry too much about the saving and stuff. The main thing is that it must work. All right, the main thing is that it must work, and just so that you learn how to work with our interface, how to inherit from it. Okay, and I think we can call it there. Don't worry, I'll share the link again on the actual WhatsApp group just for your guys' convenience, and I'll also post the video on YouTube as usual. Let me stop sharing my screen now. It does. That one does sound quite awesome. I should have called it that. Make your own enemy. But then we might have a bunch of other people, not from our course, coming in and forking the code as well. Although that's not a bad thing, obviously. Yeah. Goodbye, guys. I must stop sharing my screen first. Stop recording as well.